Good afternoon, everyone, and thank you so much for joining us today. On behalf of BM Infotrade, I would like to welcome you all to this exclusive webinar on DevSecOps Security Without Compromise. My name is Anushka Mathur, and I'll be your host for today's session. And I am joined today with my co presenters, Divya Sharma, Priyanshi Sharma, and Rahul Sharma. We are really excited to have you with us as we discuss how organization can integrate security seamlessly into DevOps practices without slowing down the innovation. Before we begin, let me quickly take you through the flow of today's webinar. I'll start with a short intro about our company, BM Infotrade, in which I'll walk you through our mission, vision, and the value we bring to our customers. After that, we'll dive deep into today's main topic, DevSecOps. And finally, we'll wrap up the session with a little Q&A round where you can share your questions with us. Now, before we get into the topic, let me give you a quick introduction about our company. So, BM Infotrade has been in the IT industry since 1996. That's about 29 years of experience now. Over this time, we have worked with enterprise customers across various industry variables to modernize and secure their infrastructure. We have two main line of businesses: volume businesses, where we provide IT hardware like laptops, desktops, servers, storage, firewall, networking equipment, and security devices, and more. And second line of business is technology business, where we focus on four main areas, which we'll discuss later on. Following up with our mission and vision, our mission is to be the go-to partner for our customers to really understand their challenges and solve them with the right technology. Our vision is to build strong long-term relationship with customers by consistently delivering value and innovation. Here's a little leadership thought by our director, Dr. Mukul Gupta. Under his leadership, we have been dedicatedly providing our customers great services that truly make a difference for our customers. Here's To give a quick overview of what we do, I would like to move on to our organization chart. In cloud, we provide end to end planning, architecture design, deployment, optimization, and cost saving across Azure, AWS, and GCP. In data and AI, we have specialized team in analytics, engineering, and data science, building everything from pipelines to Power BI dashboard and AI-driven applications. In cybersecurity, we operate a 24/7 SOC with ethical hackers and security professionals, implementing SIM tools and protecting enterprise at scale. In digitalization and automation, we work on low-code, no-code solution with Microsoft Power Apps. We have also built a center of excellence where we have implemented solutions ourselves so our customers can see live demos and real ROI benefits before deploying it to their own environment and infrastructure. So, thank you so much. This was it for our company profile. I would like Priyanshi to take over from here and walk us through how enterprises can implement DevSecOps efficiently and securely.
Hello everyone, this is Priyanshi and thank you for joining today's session. In today's session, we will discuss on DevSecOps and how we are transforming the software development lifecycle by integrating development, security, and operations into a unified process. Our goal is simple: to deliver faster, innovate smarter, and stay secure in an environment where cyber threats are evolving at lightning speed. To understand why this transformation is critical, let's first look at why security plays such a vital role in modern DevOps. In today's fast paced delivery cycle, speed without security is a risk multiplier. Attackers now exploit vulnerabilities not just in code but in infrastructure, third party libraries, and APIs. So, without embedding security into DevOps, vulnerabilities reach production faster than ever. The risk includes in this is data breaches that is causing financial and reputational damage, compliance failures which is leading to penalties, and customer trust degradation which is impacting business growth. This is why security can no longer be a checkpoint at the end. It must be continuous, automated, and integrated into every stage of development. So, DevSecOps is not just a framework, it's a mindset shift. We have embedded security controls and automated checks into the entire software development lifecycle, from planning to production. Our approach includes automated vulnerabilities scanning in code, dependencies, and containers, continuous monitoring to detect and respond to threats in real time, compliance as code to enforce security standards consistently. With this, security becomes a shared responsibility between developers, operations, and security teams. And the result is faster releases, fewer risks, and strong resilience. Now, let's dive deeper into how we implement this strategy using the shift left and shift right security models. Modern software delivery demands both speed and security, and that's where the concept of shift left and shift right security comes into play. Shift left security focus on integrating security practices early in the software development lifecycle. Security checks are embedded right from planning, coding, and building stages. Using techniques like SAST, SCA and IAC scanning, we detect and fix vulnerabilities before they reach production. This reduces remediation costs, it, it minimizes risk, and ensures secure code delivery. On the other hand, shift right security extends these controls into deployment and production environments. It involves real time monitoring, dynamic application testing, and threat detection once the application is live. With tools like DAST, SIM, and observability platforms, we identify anomalies early and respond rapidly to incidents. By combining shift left and shift right approaches, we achieved end to end security coverage and securing application before deployment and protecting them continuously after releasing. Now, I would like Divya to take over and look deeper into the individual techniques we use under each approach.
So now that we have established what DevSecOps is and the meaning of shifting security both left and right in the software development lifecycle, let's focus on the pre-production or shift left side of the equation. So shifting security left ensures security becomes an enabler and not a bottleneck. So here are some of the techniques of shift left security: static application security testing, software composition analysis, software bill of materials management, infrastructure as code scanning, pods and container security, and secrets management. So now that we know several shift left techniques, let's focus on static application security testing or SAST. So it inspects your application's source code or binaries without executing them to find security flaws early in the build stage. So it performs static white box analysis so you can catch issues before artifacts are produced or deployed, integrating naturally into the PR checks and the CI builds as an automated security gate. So SAST commonly identifies injection flaws, for example, SQL injection, cross-site scripting, and other code injection issues. It also identifies hard-coded credentials and insecure control flow or even business logic errors. So results are typically actionable, pointing to a file or line location and suggested fixes so that developers can remediate quickly during the normal development workflows. So while SAST gives fast, cost effective, early coverage and improves developer security feedback, you can also expect tuning for false positive and remember that it won't find runtime only problems like deployed misconfigurations. So we should always use it as a part of a layered approach alongside of SCA, DAST and IAC scanning. So here is a glimpse of how SAST actually works. You can see the file path and the file line given here, and it has also given us how many critical, high, medium, or low vulnerabilities are present in the path. It has given us the code analysis, the Docker file, and the package JSON vulnerabilities too. So, in modern software, most applications rely heavily on third party libraries and open secure components. So, like even the code that you didn't write yourself. So, software composition analysis tools automatically scan your project's dependency files like package.json, pom.xml, or requirements.txt to create a clear inventory of all the components, including indirect or transitive dependencies. So, this makes sure that you have full visibility into everything your app includes. So, once SEA has identified every component, it checks them against known security vulnerabilities like CVE, NVD, to even flag outdated or dangerous versions. So it also analyzes the licensing of those components, highlighting any sort of potential legal or compliance issues. These insights are presented clearly and often include recommended fixes or updates to minimize the risks. So, by integrating SCA into the build stage itself, we can automatically detect these risks like vulnerability dependencies and maintain packages before they reach our production environment. So, this helps our code base to be secure and compliant without slowing down the whole development. So, here is a glimpse of how SCA actually works. So it gives us the vulnerability IDs, the severity, the installed version, and what would be the fixed version of it, and even the title. Next is software bill of materials management. So a software bill of materials is essentially like a machine readable ingredient list of everything that goes into our software, from code libraries and frameworks to licenses and versions. So it includes both direct and indirect components and give us full visibility into what our software is actually made of. So we generate an SBOM for every build to automatically track every component used, including versions, licenses, and known vulnerabilities. So, this whole inventory helps us catch undeclared or malicious components and also identify components like affected CVEs and flag any potential license violations. So, in short, SBOM management at the build stage ensures that we know exactly what's in our software, where it came from, and whether it creates any legal or security risk. So, this empowers us to act quickly when vulnerability surfaces, keeping our supply chain both safe and compliant. Next up is infrastructure as code scanning. So, infrastructure as code scanning automatically reviews our infrastructure configuration files like Terraform, ARM, Bicep templates, Kubernetes YML, or Ansible scripts during the build stage itself. So it catches dangerous misconfigurations early, such as overly permissive network rules, insecure access controls, unencrypted resources, or violations of security best practices before anything is deployed. So by scanning these templates, SCA tools helps us prevent risks like exposed cloud resources, for example, a public S3 bucket, weak IAM policy, and other configuration flaws. This helps us ensure that our infrastructure is secure by design, not an afterthought. So integrating IAC scanning into our CI/CD workflow means developers get an instant feedback on their issues. So now I would like to invite Priyanshi again to explain the remaining parts of the shift left security.
All right. So, as we adopt containerized architecture, Kubernetes plays a critical role in managing and scaling application efficiently. However, this shift also introduced unique security challenges that must be addressed proactively. Our security approach focus on three layers. First is image security, where every container image is truly scanned from vulnerabilities before deployment, ensuring only secure images enter the environment. The second one is configuration security, where manifests and configurations are reviewed to eliminate misconfiguration, such as overly permissive roles, exposed services, or insecure access control. And the third one is runtime security and compliance, where once workload are deployed, we implement continuous monitoring to detect, anomalize, and enforce compliance with organizational security policies. This end to end security strategy ensures that our containers and Kubernetes environment remain secure, compliant, and resilient throughout the entire application lifecycle. This screen displays the result of a container image vulnerability scan. The scan analyzes the container image and identifies security vulnerabilities in its components and dependencies. Here we can see the finding categorized by severity levels. Critical vulnerabilities, which is pose the highest security risk and must be patched immediately. For example, in this case, vulnerabilities were detected in commonly used libraries like curl and git, with details such as vulnerability IDs mapped to known CVs for references. And the second one is affected versions, that is showing which version are impacted. And the third one is fixed version, that is indicating the secure version we should upgrade to. By integrating such scans into the development pipelines, we ensures that only secure container images are deployed, reducing the attacks surface and maintaining compliance with organizational security standards. Now that we have seen how vulnerabilities are detected, let's move on to how we manage secrets and protect sensitive data in our environment. In modern applications, we handle a wide range of sensitive credentials like API keys, database passwords, tokens, and certificates. If these are stored in a shared insecurely, they become a significant security risk that can be lead to data breaches and unauthorized access. To address this, we follow a structured secret management strategy in which we are doing centralized storage. All sensitive information is securely stored in encrypted location, which is preventing exposure across environments. The second one is access control. We are putting strict role based permissions, ensuring that only authorized services and users can access secrets when required. And the third one is automated rotation. Secrets are regularly rotated and given limited lifespan, to reduce the impact of potential leaks. No hard coding. Secrets are never embedded in application code, container images, or configuration files, maintaining isolation and security. So, by implementing these practices, we minimize risk, maintain data confidentially, and ensure strong protection for critical application assets. With secrets secured, we can now shift our focus to strengthening production level security under the shift right strategy. So I will pause here and pass it over to Rahul, sir, who will dive deeper into the next part of our discussion.
Yeah, hello. Yeah, hello everyone, and thank you for joining today's session on Shift Right. We have all heard a lot about Shift Left in DevOps and DevSecOps, where the focus is on testing early in the development lifecycle. But equally important is Shift Right, which means extending testing, monitoring, and security into production. So today we'll walk through some of the key practices and tools that enable shift right and help organizations ensure applications remain secure, resilient, and compliant in real world environments. So coming to the slide one, that's dynamic app security testing. So yeah, let's start with the DAST or dynamic application security testing. While static testing focuses on the source code before deployment, DAST simulates real-world attacks on a running application. It helps us catching vulnerabilities that only surface when the app is live. Things like authentication flaws, session management issues, or misconfigurations lies in this application once the application is live. So, coming to the next slide, here a tool that shows the results on a scanning of a live application. As here you can see, the vulnerabilities are mentioned, the extenders are extenders are mentioned, and vulnerabilities like SQL injections, cross-site scriptings, and HTTP header injections are mentioned, which again makes sorry, yeah. So which again makes things easier to detect the vulnerabilities while going live. Maybe this application could be an e-commerce application, a website, or a fintech website in a staging environment or in a production environment. So yeah. Next, coming on the compliance as code slide. Traditionally, compliance were checked manually, slow, and often disconnected from development. But with compliance as code, policies and regulations are translated into automated rules that continuously validate the system's compliance status. Compliance like HIPAA, PCI DSS, and CIS benchmarks uh, are like integrated with the solutions which are scanned, and the results are much more faster. Coming to the next slide, that is web application firewall, again a crucial and a major role in the application security, DevSecOps. A critical layer in a shift right security is web application firewall. It acts as a proactive shield for your applications by filtering and monitoring HTTP traffic between a web application and the internet. So here I would like to share an use case for WAF. Consider like if we assume a fintech company that notices a spike in suspicious login attempts, attackers trying different credentials, trying brute force attempts on the application. The WAF deployed in production will block these malicious requests in real time. This buys the security team a valuable time while protecting customer accounts from takeover. Now comes the monitoring and observability part. So in a world where applications are distributed across environments, across microservices and cloud environments, traditional monitoring isn't enough. Observability gives us the ability to understand the system behavior, through logs, matrix and traces. So yeah, the next part is security information and event management, similar to the monitoring and log observability part. So here, SIM is responsible to collect all the logs from the application or network infra and sorry, yeah, and when the logs are ingested into the solution, this solution is responsible to correlate the logs and yeah, raise an alert if some suspicious or malicious activities have been detected into the solution, so on which the team will be working proactively without delaying any time. So uh, the screenshot here represents the overview or some insights on the sim solution, which is here responsible to check the all the compliance as PCI DSS, GDPR, HIPAA, and NIST and CIS benchmarks mentioned in the configuration assessments. Similarly, the threat hunting part, which makes again easier for the analyst to check any suspicious activity that have been missed or that have been not detected by the solution, and so that the after detecting that particular alert that may be uh, like ingested as a use case in the solution, then comes the MITRE ATT&CK framework, which again is integrated with the solution and will display all the TTPs, tactics, techniques, and procedure that have been uh, taken out to carry an attack or an incident. Similarly, we get threat intel platforms integrated here, which will again detect the IOCs and stuffs. Yeah, so coming to the next slide, incident response and alerting again plays a crucial role in the environment, in the security environment. So even with all the preventive measures in place, incidents are inevitable. What matters is quickly and effectively we respond. So an alert is once an alert is triggered, an incident is occurred. What were the necessary steps and what were the investigation process that have been carried out by the analyst, which will be documented, and what were the lessons learned from that alert or incident that should not be happened in future will be documented, which again will save a lot of time, and yeah, which again will also highlight the alert before indicating like before getting successful. So coming to the conclusion part, so shift right is not about replacing the shift left, instead it complements it. While shift left ensures we build secure applications from start, shift right ensures that our applications remain secure, compliant, and reliable once deployed. DevSecOps itself is a continuous cultural transformation, not just a checklist. It integrates security across the entire software development lifecycle from planning through production. Security becomes a shared responsibility, fostering collaboration between development, operations, and security teams, and embedding a proactive mindset that scales as threats above. Yeah, so thank you so much for your time today. If you guys have any questions or any questions or queries, please shoot it to us.
If any of you have any questions, you can type it in the chat box or can just unmute yourself and shoot your questions, please.
Yeah, hi Bharati. We have got your question here. Can I know more about what is XDR? Yeah, actually, the webinar XDR is an extended detection and response solution, and that is a different topic instead of DevSecOps. So yeah, we could discuss it in the next webinar, maybe. Uh, yeah. So if you have any questions related to DevSecOps, you may please proceed.
Okay, I think nobody has any more questions. Thank you so much, everyone, for joining us today. We hope the session gave you some useful insights on DevSecOps. Please feel free to connect with BM Infotrade for any further discussion. You can contact us via our website, LinkedIn, or directly contact our sales team as well. Thank you. Thank you so much, everyone.